Chapter 11, number 10. Four Newton forces, A through D, are acting on a 3 meter by 4 meter piece of plywood that has a pivot point at P. Will the plywood rotate about pivot point P clockwise, counterclockwise, or not at all? So we're really looking for our net torque. The first thing we should always do after getting reading a problem is to draw forces and their lines of action. So I'm just going to give these guys each a unique color so that we can talk about them later. So we have that. And then each one has a line of action, which is the vector that contains it. So the purple guy has that line of action, and the green one has this line of action, and the blue one has that line of action, and the red one has that line of action. One of the reasons that that's useful to do is that we can see if our line of action passes through the axis. For instance, for the red force, for force A, that's true, therefore the moment arm is 0, therefore the torque due to A is 0, and I can now stop considering it. For the other ones, we might want to say, well, who moves which way? So if we look at force C, the moment arm for C is this, the shortest distance between the pivot and the line of action. That has clearly length 2, and it would tend, if you imagine pulling on this in the direction of the force, it would tend to spin the object counterclockwise. So we'll call that a positive torque, and we'll say that tau C is the 4 newtons times the 2 meters, or 8 Newton meters. If we look at force D has this as its moment arm. That's the shortest distance between the pivot and the line of action. That also has 2 units, but if we notice, D will tend, as we pull this way, D will tend to rotate the object that way, which is clockwise, and in our usual formulation, clockwise is negative. So it would be negative times 4 newtons times 2 meters, or minus 8 Newton meters, which is interesting because C and D are therefore obviously just doing opposite effects, and so they have canceled out as well. So in the end, it all comes down to B. I don't actually need to compute B's torque, since it's the only one that's going to matter, but I do want to say what the moment arm would be. So the moment arm would be the shortest distance from the pivot to the line of action. So this new thing is our moment arm. If we take that and we pull it in the direction of B, that tends to move the thing in a counterclockwise notation. So we have that tau B is positive, which means being is when we sum all of them up, we have 0 plus something minus something plus a new thing. So our tau net is also positive. Which means that it moves counterclockwise. Our correct answer is this one.